Hi, and welcome to the segment of Quick Math about the equation y equals mx plus c. Before I speak more about the equation, it is worthwhile that I deliberate on linear patterns. These are patterns where the difference between the adjacent items are the same throughout. For example, in 1, 2, 3, 4, 5, its adjacent items are different by 1 throughout. As in 2, 4, 6, 8, 10, its adjacent items are different by 2 throughout. And as for 3, 6, 9, 12, 15, the adjacent items are different by 3 throughout. And as in -1, -2, -3, -4, -5, the adjacent items are different by -1 as the pattern progresses. Now, what can be said of the linear pattern of 1, 2, 3, 4, 5 is the first or number 1 item of the pattern is 1. The second or number 2 item of the pattern is 2. The third or number 3 item of the pattern is 3, and so on. Imagine stating this as the xth or the number x item of the pattern is y, and then describe y in terms of x, and this should lead us to y being equal to x. In executing the same for the linear pattern of even numbers 2, 4, 6, 8, 10, the first or number 1 item of the pattern is 2. The second or number 2 item of the pattern is 4. The third or number 3 item of the pattern is 6, and so on. Again, imagine stating this as the xth or number x item of the pattern is y, and then describe y in terms of x. This leads us to y equals 2x. As for the linear pattern of 3, 6, 9, 12, and 15, when stating the xth or the number x item of the pattern is y, and then describe y in terms of x, this leads us to y being equal to 3x. And for the linear pattern, -1, -2, -3, -4, and -5, y is equal to -x. Next, we're going to plot these patterns on a graph with its x-axis representing the x item and the y-axis representing the pattern itself. The blue dots on the graph are the plots for the pattern 1, 2, 3, 4, 5, where y is equal to x. This takes us to our first tutorial walkthrough question. What is observed from the plotted dots? They are in linear alignment, aren't they? We shall now add the plots for the pattern 2, 4, 6, 8, 10, where y equals to x. They are also in linear alignment. And further plotting the pattern 3, 6, 9, where y equals 3x, they are also in linear alignment. For completeness, here is the plot for the pattern -1, -2, -3, -4, -5, where y is equal to -x. As for our second tutorial walkthrough question, how are the red dots different from the rest? The red dots slope downwards moving from left to right, whereas the other dots slope upwards moving from left to right. As for our third walkthrough question, what is the purpose of a graph? Why do we even bother? As for things that are linearly correlated, the graph can help us to better make linear projections. For example, ever observed that your treadmill can tell you how much calories you burn? Ever thought about how much material you need to buy to make the end product you require? In math, you can plot a scatter diagram from the data you gather and put a line of best fit to achieve the above. Now on to equation of a line. Mathematicians love to associate patterns. Hence, when linear patterns are plotted on the graph, a line is placed on top and is equated to the linear equation y equals mx plus c. Let's start with its simpler form, when m is 1 and c is 0, leaving just x and y. In this case, the y equals x generates the coordinates 1 and 1, 2 and 2, 3 and 3, 4 and 4, 5 and 5, and so on. Let's do more points on the graph. This line is the equation y equals x. And this brings us to our very first key point. For the equation y equals mx plus c, x and y represents the coordinates on which the line sits on top. For our fourth tutorial walkthrough, let's plot the coordinates and line for y equals x plus 1, for y equals x plus 5, for y equals x minus 2. Do you see a pattern between where the line cuts the y-axis and the value c? The value of c is the same as the value of y at which the line cuts the y-axis. Hence, our second key point for the equation y equals mx plus c, with c being the value of y where the line cuts the y-axis. For our fifth tutorial walkthrough, let's plot the coordinates and line for y equals 2x, for y equals 3x, and for y equals minus x. Do you see a pattern between the line gradient and m? We should note that the vertical to horizontal ratio of its gradient changes in proportion to the m value. Also, the slope flips, moving from a positive to negative m value. Hence, our third key point for the equation y equals mx plus c, with m being the gradient or slope of the line and a determinant for the type of correlation. Tutorial walkthrough 6. What is the equation of the line on the diagram? With the gradient m being half and the intersect of the y-axis c being 7, y is equals to half x plus 7. Tutorial walkthrough 7. What is the equation of the line that cuts through the coordinates minus 3, 0 and 0, 6? By making x1, y1 being equal to the first coordinate and x2, y2 being equal to the second, m can be deciphered by the differential in the y values of the two coordinates divided by the differential in the x value of the two coordinates. By doing the math, this comes to 2. Separately, c can be deciphered as 6 from the given coordinates 0, 6. Therefore, y is equal to 2x plus 6. Tutorial walkthrough 8. Plot the equation y equals minus 3x plus 2. With c being 2, the line would have a point with coordinates 0, 2. The required line is simply the plot of a line with gradient minus 3 that cuts through this coordinate. Tutorial walkthrough 9. Plot a parallel line to y equals minus 3x minus 3 that cuts through the y-axis at 2. The required line will have c being equal to 2, as this is where the line cuts the y-axis, and m being equal to minus 3, as it is parallel to the line y equals minus 3x minus 3. With that, we should be able to plot the line in accordance. Tutorial walkthrough 10. Plot the equation 2y equals x minus 4. In such an instance, you want to rearrange the equation such that its left-hand side starts off with a single y. With that, we should be able to plot the line in accordance. Tutorial walkthrough 11. Plot the equation y equals 8. This is a horizontal line that cuts across the y-axis at 8. This equation has no x component because its m component is 0, which is a line with 0 gradient. Another way to think about this is y equals 8 irrespective of what x is. Tutorial walkthrough 12. Plot the equation x equals 0. Here, x is 0 irrespective of the y value. The line x equals 0 is the red line on the diagram, and it sits right on the y-axis. Tutorial walkthrough 13. State the coordinates at which the equation y equals 5x plus 10 cuts the x-axis. At the x-axis, the y value is equal to 0. Hence, we can equate 5x plus 10 to being equal to 0. With that, we can decipher x as being minus 2. Therefore, the required coordinate is minus 2, 0. That's all for this segment. Do visit our other segments of Quick Math if you found this beneficial. Bye bye for now.